What's up guys, Onmaths here. We're mainly going to be focused on recurring decimals for this video, but I thought I would put this question in because however good you feel, however confident you are in maths, sometimes a simple question like this can throw you off if you don't know how to answer it. Now there's loads and loads of different ways of answering this question. I'm just going to show one method. We're going to do kind of the cross multiplying or whatever. There's loads of names for it, but it might not be a method you've seen before, or it could be one that your teacher has told you that it's not a very good method, or a teacher told you is a very good method. It just really depends on who your teacher is. So with this we draw a grid, and what we're going to do is we're going to fill in the decimals in kind of 1 digit per place, like that, and then the 4.3 goes down like that. And what we do is we put some diagonals in, and let's get the diagonals in like that. I'm really bad at drawing this. It's supposed to be square, but you get the picture. Okay, so what we're going to do is we're going to times each of the numbers inside the grid. So we've got a 5 there and a 4 there. So 5 times 4 is 20. We put the tens at the top left and the units at the bottom right. So next we're going to do 4 times 4, which is 16. 6 times 4 is 24. 5 times 3 is 15. 4 times 3 is 12. 6 times 3 is 18. Right, the next step is we're going to add up going diagonally. Okay, so we're going to add this one first, and we're going to put the answer down here. Then we're going to do 2 plus 1, which is 3, plus 4, which is 7. Then we're going to do 5 plus 1, which is 6, plus 6, which is 12, plus 2, which is 14. So it's a 4 there, and then we put a 1 down here. Then we're going to do 1 plus 1, which is 2, plus the 1 we carried, which makes 3. And then finally we've got that 2 there. And you can imagine that's kind of going down there, and that's going down there. Okay, the last step is to figure out where the decimal point is. Now this is where it gets quite clever, because if we keep going down from this decimal point here, and keep going across from this decimal point here, they do eventually meet. And then if we keep the diagonal from where they meet, keep going down the diagonal, that shows us where the decimal point should be. And so the decimal point should be here. So the answer is 234.78. It's a really, really nice method because you're only ever timesing things together. You're not really adding large numbers together, and you can do it all in one step, and it's quite easy to check. Now, I'm not saying this is the only method. I'm not saying this is the best method. But if you haven't seen this method before, it might be worth giving it a go and practicing it, and obviously using your calculator to figure out whether you've got the right answer. Because for some students, this is a much quicker method and a much more reliable method in getting the right answer. Next, we move on to our OCR question. And this one's quite a sneaky one because it's just given us a fraction and asked us just to find the recurring decimal. Now, I can think of another longer way, but the simplest way of doing this is just to do bus stop method, I would imagine. And if you've got a different method for doing this that you think is better, fine, stick with it. Let me know in the comments below. So to do bus stop method, we put the 12 on the outside, so this one always goes on the outside, and then the 5 on the inside. Now we know that 12 doesn't go into 5, so what we need to do is just add some zeros here. Okay, because we're going to have some carries, some remainders, I suppose. 12 into 5 does not go, so 0. Okay, and we carry that 5. So 12s into 50 go 4, with 2 remainders. 12s into 20 go 1 with 8 remainders. Now 12s into 80, 12 times 6 is 72, so 6, but there's 8 remainders. Then 6, 8 remainders, 6, blah blah blah. Okay, so we're always going to have 8 remainders that will generate another 6, that will generate another 8 remainders. So that's where we get a recurring digit. So we've got 0.416 recurring. Now be careful to have just the recurring dot above the 6, because it's only the 6 that's recurring. Right, the next question, you might be able to just answer, especially when you've done a few of these, you notice there's a pattern, but the question sometimes says you must show algebraically how. In fact, sometimes the question actually gives you the answer in the question and says, show that 0.76 recurring equals this fraction by using algebra. So I think it's a good idea to use the algebra. Now I'm going to leave some space above, and I'm going to say that x equals 0.767676, okay, which is what 0.76 recurring looks like. Now the whole point of this exercise, the point of this next step, is to get the recurring digits in front of the decimal point, okay, and to do that we times it by 100. Okay, we times it by 100 because there's 2 recurring digits. There's the 7 and the 6. Okay, so we're bringing them in front of the decimal point. 7676, blah, 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 blah. Okay. Next, we're going to take away the 100x from the x. Okay, we're going to take away both sides. And so let's just kind of demonstrate that a little bit, what we're doing. So 100x take away x is 99x. Simple. And then 76.767676 take away the 0.767776 just equals 76. Okay. Then we get our lines down, and what we're going to do is we're going to divide by 99 both sides. Now we don't actually want to actually divide because obviously that wouldn't make a fraction, so we just write that as a fraction, 76 over 99. So the answer is 76 over 99. Now, the reason I said some of you probably knew that even before we started the question is that if there's 2 recurring digits, it's always over 99. If there's 1 recurring digit, it's always over 9. And it just carries on. So if I had, I don't know, 4 recurring digits, then that would be over... So 1 recurring digits over 1 single 9, 2 recurring digits over 2 9s, like 99, and so this would be over 9999. Okay, it's as simple as that. Now there are more complex questions, obviously, there always are, but just getting the habit of showing algebraically is really important because the question sometimes asks you to do that. And our last questions with AQA, and lo and behold, the prophecies come true. We're given the answer in the question, and we're asked to show that this equals this. Now we are given a fact that 0.7 recurring is the same as 7 over 9, so that's just given. So we have to use that fact to be able to show that 0.07 recurring is the same as 7 over 90. And actually this is probably easier than it looks, because if we get that 0.7 recurring and we divide it by 10, that equals the 0.07 recurring. And so all we need to do is get that 7 over 9 and divide that by 10. When you divide by 10, I mean, there's loads of different ways you could do this, but you could do same, change, flip. So same, change that to a times, flip that, and that becomes 7 over 90. And so therefore 0.07 recurring is the same as 7 over 90. Simple as that. Okay, the next question asks us to use the knowledge gained in part A and convert 0.27 recurring to a fraction. So the first thing to realise is that 0.27 recurring is just 0.2 plus 0.07 recurring. Now the reason why we've split it up is that we already know what 0.07 recurring is. We know that that is going to be 7 over 90. And 0.2 is what, 2 over 10 or 1 over 5. Now that doesn't help us to completely finish the question, because we need to add these fractions. So to add the fractions, we need a common denominator, and it looks like it's going to be 90. So we're going to have to times the 1/5. We're going to have to times top and bottom of that fraction by a number to get to 90, which would be 18. So it's going to be 18 over 90 plus 7 over 90. And then add the tops, which would be 25, and the bottom obviously stays the same. So it's going to be 25 over 90. Now, it does say in its simplest form, so we do need to cancel this down. So 5 goes into both of those. So it'd be 5 over 18, and 5 doesn't go into 18, and 5 is a prime number, so it's just going to stay at that. So it's going to be 5 over 18. Well, I hope you found today's video useful. If you did, please click like. If you want to see more from us, we release videos every single weekday at 9 o'clock. So just click subscribe and the bell icon. You'll be up to date with all the videos we release. If you want to see even more from us, which I'm sure you do, you can click the link at the top of this video right now to take you straight through to our website, onmaths.com, which is packed full of completely free resources to help you with your maths. Otherwise, thank you very much, and I'll see you tomorrow.